Hi folks, welcome back to the 6.3 practice, and we are taking a look at question number 3. In the previous video, we solved a problem where we were revolving this around the y-axis, and we talked about why we had to choose washer, or we didn't choose washer, but rather we chose shell method. And so now we're going to take a look at the situation where we're revolving this around the x-axis. And we're going to talk about some same things like should we use washer or should we use shell? So let's see what would happen if I wanted to use washer. So if I wanted to use washer method, then my lines need to be perpendicular to my axis of revolution. That would mean I would have to draw lines like this. Okay? Now, if I wanted to use shell, I would have to draw lines that are parallel to my axis of revolution. Or I would have to draw something like this purple line. Okay? Now, let's see, which one is going to be problematic? Well, my eyes are immediately drawn to that shell method because the height of the shell is going to go from the orange curve to the orange curve. So that's not helpful to us. But if I look at the washer one, I have a top curve of orange and a bottom curve of blue. So we're going to go with washer method for this particular question, all right? And before we do that, I'm going to get rid of the shell line so we don't get confused. Okay. So if we're going to set up our washer method, we don't want the 2 pi RH, we want pi r squared. So my volume is going to equal pi times the integral from a to b of r squared dx. Now I could also say, let me do washer method with the big R squared minus the little r squared just in case, okay? So maybe let's erase this and try it that way. So big R squared minus little r squared dx. Now I have pi, I go from 0 to 2. Now which curve is further away from the axis of revolution, the orange one or the blue one? Well, I think when we look at this, we can see that the orange one is further away, and so our graph of 2x minus x squared is our big R, and we have to square it because we have big R squared. All right, so the orange curve is our big R, and this is our orange curve. Minus the second line is actually just 0, so 0 squared would be our smaller radius. All right, so this is the blue line, and this is the equation of the blue line. Now, if you could recognize from this picture that you don't need to have the little r, that's totally fine. You don't have to write it, but I think as we're learning how to make decisions, sometimes writing more is actually helpful. All right, so now let's simplify. We've got pi times the integral from 0 to 2 of, let's FOIL that out, we'll get 4x squared minus 4x cubed all right, 4x cubed plus x to the 4th dx. All right, and it looks like we're ready to integrate. So pi 4/3 x cubed minus x to the 4th plus 1/5 x to the 5th. I'm going to plug in 2, and I'm going to plug in 0. All right, now I'm going to do a visual check. I notice that if I plug in 0, everything will go to 0, so I don't have to write it. That will leave me with 4/3 times 2 cubed minus 2 to the 4th plus 1/5 times 2 to the 5th. That will give us pi times 32 over 3 minus 16 plus 32 over 5. And we're going to go ahead and find a common denominator of 15. And that will make 32 into a 160. That will turn 16 into a 240. And that'll turn 32 into a 96. And when I work that all out, I will get 16 pi over 15. All right, let me zoom back out so we can see the whole problem. But as we can see, we did not get the same answers for A and B, and that's okay because we didn't have the same resulting shape. All right, these are two separate problems. And in both problems, we had to decide, should we use washer or should we use shell? Okay, so that's it for this video. I've got one more example to work through with you, and we're going to do the same kind of thinking where we decide based off of the picture, should we use washer or should we use shell? All right, I'll see you there.